The following labs intend to supply you with a comprehension of the relationship between pressure, temperature, and humidity, providing you with the ability to explain the theories and laws associated with the above relationship, while gaining an understanding of each topic discussed. Lab procedure number 1. What you'll need is a pot of boiling water, a bowl of ice cold water, temperature probes, a bottle with 1 ounce of water, and a balloon. The following demonstration will show the relationship between temperature and pressure. I have already set up the first part of the lab to save some time on the video. Both the pot of water as well as the water inside of the bottle are already at 100 degrees. There's a bowl of ice water sitting at a cool temperature of 5 degrees Celsius, of course. Using Prepper PPE, I'm going to remove the bottle from the hot water and put a balloon over top. I'm going to put it back in the hot water. What do you think is going to happen to the balloon? Let's find out. Since I removed the bottle from the water with high thermal energy to install the balloon, introducing air around it with less thermal energy, the balloon began to suck into the bottle automatically. I originally wanted to show the balloon's pressure increasing versus temperature increase, thermal energy, first. As you can see, the thermal energy, temperature, inside of the bottle is increasing, creating an increase in pressure, therefore inflating the balloon. I'm going to take the bottle out of the hot water and put it in the ice cold water. What do you think is going to happen to the balloon? Let's find out. Sometimes you just need a little help there. As you can see, the thermal energy, temperature of the water and the air inside of the bottle is decreasing because of the ice water, and therefore the pressure is decreasing, sucking the balloon inside of the bottle.
From my experiment, I'm going to make a cloud to show the relationship between humidity, temperature, and pressure. Let's talk about this relationship before we begin our experiment. Humidity is inversely related to temperature and pressure. The more pressure and temperature we have, the less humidity. The less temperature and pressure we have, the more humidity. Let's talk about how a cloud is formed. Air and water on or near the surface of the Earth is at a higher pressure than air that is thousands of feet above us. If we heat this air and water near the surface of the Earth, the molecules of both the air, N2 and O2, and the water, H2O, begin to build kinetic energy and start to move rapidly. When the water warms enough to evaporate, it joins the air and eventually replaces either an N2 or O2 molecule. This interaction causes the air to become less dense, or a lower pressure air column is created. This air column starts to rise, and as it rises, it begins to cool. Eventually, it cools enough for the water to condense and form a cloud. Now that we have a better understanding of this relationship, let's make a cloud. All right, so to make the cloud, you need a bottle. In the cap, I just screwed a quick hole. I put a bike valve in there. You'll screw that on the top. Inside the bottle, you'll put a little bit of rubbing alcohol. Swirl the rubbing alcohol around. This just gets more of the rubbing alcohol's vapors into the air. Take a bike pump and install it on the top and start pumping it up to build the pressure. Just gonna do this for, I don't know, about 30 seconds, because it depends on the pump you have. Move the pump, take the lid, screw it off. Ooh, Jesus, that thing went flying. And look, you have a cloud. All right, 1 second. Be back. Now, if you take the pump, put it back on, and pump, the cloud will eventually disappear. Do it again. You have a bit of a cloud. Now what's going on is as we pump up the bottle, we're increasing the pressure and the temperature in the bottle. This is warming up the alcohol molecules and allowing them to replace the molecules in the air as a normal cloud's being formed, would be formed in real life. When we release the bottle, all that low pressure air has now rised, and the quick change in pressure and temperature causes all the water vapor, or in this case alcohol vapor, to condense instantly and create a cloud.
That's all, folks.